This next video is on the power rule. So we've had the product rule. When multiplying powers of the same base, you add the exponents. We've had the quotient rule, which is when dividing powers of the same base, you subtract the exponents. Then we had zero exponents, which anything to exponent zero is 1. Negative exponents, you're in the wrong place. And then our last rule here is the power rule before we combine them all together. So the power rule is that anytime you have a power, so a base raised to an exponent, raised to another exponent, you multiply the exponents together. So if I had something like x squared all cubed, this would be x to the 2 times 3, which would give you x to the 6. The reason why is that x squared is x times, whoops, not 2, x times x, and then you're cubing that x times x, meaning you're timesing x times x by itself 3 times, which gives you 1, 2, 3, 4, 5, 6 x's. So it would give you x to the 6. So the shortcut is, instead of having to write it all out, we're allowed to say that this is 3 sets of x squared, which would give me x to the 6. So when powers are raised to exponents, you multiply the exponents. A little extension of that rule is that if you have more than one power in your power, like if you have more than one base in your power raised to an exponent, that the exponent would go to both. So you would multiply the exponent on the a by m, and you'd multiply the exponent on the b by the m. Same thing if you had a quotient. You would then go, this is a to the 1 times m, this is b to the 1 times m, which would give you a to the m over b to the m. If you ever see your textbook throwing in stuff like this, it's because our textbook is very particular about how they show work, and they're just showing you that anytime you put a variable in an exponent, that it cannot equal 0. And they're just very adamant about showing that over and over again. Like this question here, I probably should have put m cannot equal 0, because as soon as you have an m in a denominator, it's not allowed to be 0. But I get lazy and don't put it in there. But I just wanted to explain why that was there. All right, let's try these questions. So for this one, I have r to the 5 raised to the exponent 4. So my rule of thumb, because people get really confused between when to add and when to multiply, when they're touching, multiply them. So 5 times 4 is 20. For this one, this is the tricky one. So you have to see that there's 2 bases in this power. So this is negative 3 to the 1. And then this is y to the 5. So this is going to be negative 3 to the 2. And then it's going to be y to the 5 to the 2. So in other words, you'd have negative 3 squared, which is 9. And then you'd have y to the 5 times 2 is 10. If you have a question like this, right, this is 3/4 all squared, or you can think of it as 3 squared over 4 squared, which would give you 9 over 16. Last one here, I threw this one in because there's this negative sign to try to trick you. What I want you to think of that is as a negative 1. So this will be negative 1 squared, and then you have the n to the 4, which is being squared, and then you'll have the m squared, which is being squared. So don't forget, anytime there's a coefficient, it's kind of like this negative 3. It needs to get the exponent as well. Make it part of your repertoire. So that negative 1 squared is just 1. Then I'd have n to the 8 over m to the 4. So go and practice these questions, which are just product rule questions, because then we're going to add in negative exponents.